All right. Hello, everybody. It's a fine 5 p.m. on Friday, and we're here for our Raspberry Pi workshop today. So for those that may be watching the recording later, and even for those that are just here, I think it's probably good to introduce ourselves first. So I'm Matt. I'm one of the X1 leads for this year. And, I would say that I'm probably working a bit more on the Bolt project than Broombot. It's sort of my focus. And I noticed that a lot of the team wanted to learn more about Raspberry Pi and to sort of get familiar with both the programming environment and the actual functionality of the Raspberry Pi. So I decided to create this workshop. Rebecca, would you like to introduce yourself?
Yeah, sure. So I'm Rebecca. I'm the other X1 lead. I'm more focused on the Broombot project. So Matt's mainly been in charge of this workshop, and he can take it away. Quick note for you, Matt. I just remembered, minimize your video participant screen, so it's just taking up a corner of the screen. Because if you record with the whole bar down, it'll cover up like half of the slides. I realized that I accidentally did that on the last on the design review that we recorded. So don't do that again.
Yeah, and don't worry. Yeah, I got it.
Okay.
Shoved up the corner, so we're all set. Okay.
All right, that's all. An introduction from me.
Yeah.
Take it away.
Very nice. Sure. So here's just a table of contents. This is everything I'm going to be discussing today. We're going to start with parts 1 and 2, and then 3 is a Q&A. I'll be fully honest, Raspberry Pi itself is it's a hobbyist item that a lot of people know very much about from decades of work, not decades, it's only 10 years old, but from a long time of messing around with. So there's a lot that I'd frankly say I'm not familiar with, I may not know the answer to. I can refer you to the right resources. Anyway, to get started, I'm just going to give you an overview here, and we'll get into some actual physical examples of what you can do with the Raspberry Pi. So to get started, we have a Raspberry Pi here. I mean, upon first inspection, it just looks like a circuit board, but it is much more than a circuit board. This is a full computer. A lot of people like to group it in with something called a microcontroller, which is a little bit different. I'll get into it later. But a Raspberry Pi itself is an independent, fully internet connected computer. As you can see, it has a lot of different ports here. It has USB 2.0, USB 3.0. It has an Ethernet connection here. It has a 3.5 millimeter jack. And these sort of ribbon cables are for like a monitor connection. So for to actually see what you're doing. You have HDMI, and these are GPIOs. So I think that's just the overarching message. A Raspberry Pi is a computer, right? It just may not look like it because it's simply so bare bones. It also has wireless connectivity after 2016, and there's generally Bluetooth connectivity with more recent models as well. It runs on a Raspberry Pi operating system, which is a variant of Linux. There are different variants that you can install, I think for either different reasons, different performances you want, but those are more advanced usages. In general, the Raspberry Pi OS works best, and you can get it in probably, if you got fast internet, you can just get a copy of it in around 10 minutes directly from the Raspberry Pi Foundation. So yeah, and like I mentioned, it has GPIO pins. As you can see, these are here. These are called the general purpose in and out pins. And the purpose is to either receive input, receive digital logic, or to output digital logic. And, it can end there, right? If you just have 40 bucks in your pocket and you have a monitor and a mouse laying around, and a keyboard, you can just buy this and just do whatever you want, surf the web. It doesn't have to be more complex than that. It's a complete computer. So this is just an example of the desktop, right? Not everything's going to be done with the physical desktop, but if we do so, this is an example of what it may look like. So it looks, like most other operating systems, right? We have a sort of taskbar here. We have our, file explorer example here, very similar to Windows, and I can mention Mac as well. We have our terminal. I'll be talking a lot more about this later, but this is an example of where you can sort of interact in a lower level with the actual Raspberry Pi. And importantly, you can do that without having access to the desktop. And again, we have the internet. We have some video games and stuff that you can play. And, we even have like sort of knockoff versions of Microsoft Word and such that come installed with Linux automatically, which is kind of cool. So yeah. And just to get started, I think I'd like to share, just as something a little bit interesting, is how I first encountered Raspberry Pis. And this is around 2013 when I got kind of interested in the idea of mining Bitcoin. I had a few of these little ASICs that I bought online. It's around like 20 bucks each. And I just hooked them up to my Windows computer and I was getting a little bit of Bitcoin. It was kind of fun. But what people realized pretty quickly was that Raspberry Pi is a low cost of entry complete computer. There's a lot of things you can do with that. And what some people realized is that you can simply connect a lot of these Bitcoin mining ASIC computers, these chips, and have them communicate with the Raspberry Pi, which then is internet connected. And people were doing this as early as like maybe 2014. And I don't know, just a sort of a fun fact here. If you had a device like this and I did the math on it, you would have made around 41, almost 42 Bitcoin, which is around $2.3 million if you sold it today. So, you know, I don't know where the guy is who made this, but I hope he's doing pretty good for himself. Anyway, so let's compare with some similar devices as well. First, we have the Arduino. The Arduino is shown right here. I mean, it's pretty ubiquitous. Most of us just have them laying around from just various either projects or just labs you had to take. It's a lot simpler than a Raspberry Pi. First, it has no actual interface, right? You can't simply access files or save things, or it doesn't have that nice that user interface that Raspberry Pi does. It just doesn't have one at all. So it's a microcontroller, right? Which can be defined here as a complex IC that governs a specific operation in an embedded system. So in other words, you would probably use an Arduino if you were doing something simple along the lines of, let's say if you had lights in your backyard and you were a hobbyist, where you wanted that after a certain time at night, once the light sensor reaches a certain level, then you're able to turn on a light system in your backyard or something like that. So it's used for very simple processes that require like input loops and can execute simple results from that. It's also a lot lower level, right? So this uses C. And that means that in general, you'll be interacting more with the, it's simply lower level, meaning that there's more fundamental programming involved rather than other functions that may mask some of the underlying functions, as you'll see in Raspberry Pi. No, isn't with Python as well. So yeah, it's cheaper as well. You also have the BeagleBone here. This is something I really didn't know too much about. And still, I don't know a lot about them, but I just know that these were used as a replacement for Raspberry Pi in a project I was working on. They're pretty similar. I mean, depending on which one you buy, they either have slightly better performance or slightly worse performance. They have more GPIO pins. So if you're doing something exceptionally complicated and you really want, dozens and dozens of different inputs and outputs, this might be your way to go. But it doesn't benefit from the fact that there's an entire online foundation and store built for integrated items that you can buy with it, like Raspberry Pi. So this is an example of something I worked on here. So over the summer, I was given a sensor as part of some research I did, and I was simply told read data from it. And I wanted to get the data sent through Python instead, because Python, if you know, has a lot of more intuitive plotting utilities, and it definitely supports live data plotting much better than C++, especially in a Linux environment. So I found this online. I found this particular program, which was it was given by the actual manufacturer of the product that I purchased. And it was instructions regarding getting the data, without getting into too much detail, getting the data from the actual sensor, processing it, and bringing it into Raspberry Pi. I'm sorry, bringing it in, actually bringing it into the computer. But if you do the same thing using Python, which is in general works better with Raspberry Pi, you can do this in our 84 lines. So it's a higher level language. A lot of the stuff that is sort of messy can be handled by using Python with Raspberry Pi. And it's really quite convenient, and I gotta underscore that. So yeah. Okay. So that took me a little bit shorter than expected, but I think that it's time to maybe go on to the tutorial here in regards to actually working with our Raspberry Pi. So there are two main steps. If you literally just have the Raspberry Pi and a power supply, what can you do with that? So the first step is definitely to install the operating system, and the second is to actually connect. There are two ways of doing this. This is a traditional way of actually just getting peripherals, just getting a keyboard, mouse, and monitor, and then just connecting that way. It's really quite simple that way. But if you do it wirelessly, it's a lot harder, but still manageable. So first thing is you need an operating system. If anyone's ever built their own computer before, you know that buying a computer and turning the on button is actually just a really nice luxury. If you build your own computer, you have to put the operating system in yourself. So, and it's the same thing a lot with Raspberry Pi, especially if you buy just a single board and nothing else with it. It's completely bare bones. So the process in general is one where you get the operating system image or the information for the operating system to establish itself on the Raspberry Pi, and essentially transferring that to the Raspberry Pi. So the first step is to, on your Windows computer, get the Raspberry Pi imager, which is shown here, and you're going to want to find some way to connect one of your computer ports to like an SD card. There's a bunch of different adapters like that you can find around. But essentially what you're going to do is you're going to reformat that SD card and put the Raspberry Pi imager on it. Again, this is all found very easily online. You do this, and honestly, if you have your peripherals, if you have a mouse, keyboard, and a monitor, it's really simple at this point. All you do is you just put it into the Raspberry Pi, you wait. It's just like setting up a new smartphone. All you have to do is use your language, your region, and just all these random logistical things. But yeah, if you do not have them on hand, if you have just a Raspberry Pi and a wireless connection, that's where things get a little bit tricky. Because when you don't have access to the actual desktop environment, you just can only communicate with it through the terminal remotely. So this is called a headless installation. So if anyone wants more information on that, simply look up Raspberry Pi headless installation information. And so the way this generally works is it's the same, right? You just put an SD card with the OS image into the Raspberry Pi, turns on. But at that point, what do you do? Because there's no way you can communicate with it. It's just sitting there with this fan spinning, and you're a little confused. So in sort of to go over it quickly, what you would do is you would take out the SD card, put it back into your Windows computer. I'm sure there's a similar process for Mac. And you can add certain files within the actual OS information that put both your wireless username and password in, meaning that when you put the SD card back into the Raspberry Pi, it now has the information to connect to your Wi-Fi. And it will actively be listening for connections over your IP. So there are a few different ways of doing this, and I know I have these numbers here for a reason. Basically, if you're on Windows, you're going to use this program called PuTTY, which is shown here. It's just I'm not a computer scientist. I couldn't quite tell you exactly what's going on here, but this is something that allows you to connect to different systems within your own network over, it's usually port 22 that the Raspberry Pi uses. It's listening, it's waiting for a certain signal, so you can SSH over and connect that way. And
Hey, Matt,
yeah,
quick note.
after this.
Matt, quick note.
Yep.
Yeah, so you've been saying on Windows a lot here. I just want to make a clarification. I know a lot of the people on the software team don't have Windows, they have Mac. All of this is, just as easy over Mac, I'm pretty sure. Instead of using PuTTY, you would use whatever the Mac equivalent of that is. You might be able to just do it through the Mac terminal. Yeah, but don't worry if you don't have Windows. They make it easy from whatever computer you're working with.
Yeah, definitely. Thank you. I'm just, I will admit, I'm definitely basing this off my own experience. So yeah, definitely if you have a Mac version, feel free to look more into it. I'm sure it's similar. I think there's even a PuTTY version for Mac. I looked it up quickly before the presentation. But regardless, in most tutorials you find online, there's just the Mac section as well. So definitely keep in mind that the process is pretty similar for both operating systems. So And then that's a good point to bring that up, because after this point, it's regardless of your operating system, it's the same from now on. So if you connect on PuTTY, right, and you enter your host name, in general, the default host name for Raspberry Pi is Raspberry Pi.local. And if you do so, you'll be brought to a terminal, which is essentially, you've seen it before, it's that black screen. And from there, we can continue our setup. We're going to want to run this sudo raspi config command. This is going to bring us to this sort of ugly, mid 1990s style looking menu, but it does its job. So this is where you can perform a lot of the really low level configurations of the Raspberry Pi. You can change your username, password, change your visual settings. You can even, importantly, this is an area where you can allow remote desktop connections, meaning that if you go through here, there is an option that allows you to allow remote desktop connections, which means you can actually connect to the desktop environment wirelessly as well. So also interfacing with the terminal. So the terminal, as I've shown you before, is just, it may seem mysterious. It's just it's a black box with a blinking line, but you can do almost anything with it. There are really not many things that you can do in a Raspberry Pi desktop that you can't do in the terminal. And a lot of people I know that are very good at Raspberry Pi generally don't even look at the desktop for like months on end when they're doing stuff. So because they're so fluent in this terminal speak. So these are just some terms here. These are going to make more sense in the next coming slides as I show actual examples of things that are happening. So yeah, and also here I just added a QR code. This is a giant list of all the commands for Raspberry Pi that should be pretty useful for the terminal. And yeah, there's a bunch of them. There's dozens. These are just the simple ones that are going to be shown. We have sudo, which sort of allows you to surmount the actual permissions of just the user you're using and do things on an administrator level. You have cd, allows you to change directory, means you can move files around. rm, you can remove files. Touch means you can just create a file with that certain name in a given location, and cp is copy. So I have some tasks here. The first task is pretty simple. So let's say you've done everything right. Let's say you have found a way to actually connect to your Raspberry Pi, right? You figured out all of that whole process. Maybe you use PuTTY or you use the Mac equivalent, and you're staring at the terminal, right? And, oh, sorry about that. Yeah, so say you're just looking at the terminal and you have to perform this task. So let's say you have to create one test file. Actually, you can create test file 1 and test file 2.txt in this certain directory. You're going to delete the second one, and then you're going to copy the first one here. And we'll know if we did this right, because if we look at the desktop version, it will reflect our changes, right? So let's try this out here. You can see me logging in here using the default username. Again, this is all done over PuTTY, by the way. So what I'm doing is I simply turn the Raspberry Pi on. I've already installed the operating system on it, and I connect to it. And after doing so, I'm shown this here. And I log in. I put my username and password. I think the default password is Raspberry or something. It's generally a good idea to change it the moment you get a new Raspberry Pi system.
Yeah, that's the default. Just the word Raspberry.
Okay, great. Yeah, great. Thank you. I was totally sure. But yes, so let's say we want to do our task again. So we're going to sort of move our way into this directory. So the home/pi/documents. We're going to create a test file.txt and test file 2.txt. Notice there's no comma here. We just create different files spaced apart. And then just immediately, we're just going to remove the second one in accordance with our task here. And we're going to get our test file.txt. We're going to do /home slash desktop, and that is going to move it to this given area, right? So, and you'll also notice that when you can see is when you enter in commands here, it sort of intuitively shows you where you're located, right? So this shows you just kind of at the actual base level directory of the actual user you're using, but you can navigate to the documents and you can see that here, right? A few quick tricks that I didn't write down, but I think they're worth mentioning pretty fast is if you do CD space tilde, that brings you back to the next directory, like the next largest one. So if you're in documents, this would bring you to the Pi. Or if you do CP space dot dot, so 2 dots, that's going to bring you down to the root directory again. These are all really useful shortcuts if you're doing a lot of file manipulation. So I did all that, and then I decided I wanted to connect to the actual desktop. And lo and behold, we have our home Pi documents area. We have our file left, our test file.txt, and we have our test file.txt here on the desktop itself. So, I mean, we did something right. We definitely completed our task correctly. All right. So, you know, I didn't want to add too many tasks, so I hope it's not a vertical wall of difficulty, you know, because that was fairly simple. Next, we're going to try to flash an LED upon startup, right? So what we're going to do is we're going to have it such that every time the Raspberry Pi turns on, it's going to immediately blink an LED infinitely, right? So the protocol for doing this is first, we're going to have to actually install a package because by default, Raspberry Pi does not generally connect with GPIO pins just out of the box. And then we're going to actually write a script and we're going to wire the circuit up itself. I didn't show the circuit being wired. You can just imagine it's connecting an LED with a small resistor of the right size and then putting that to the ground on the board, right? And we're going to add something to our cron tab. So our cron tab is it's called a cron table. Basically, I don't understand the deep underlying mechanism of it, but it's an area within the terminal where you can establish the execution of commands on a recurring interval, right? So that means either when maybe you start, maybe every Tuesday at 7:01 p.m., it depends. So there's a lot of different ways you can regulate tasks being done on Raspberry Pi through the cron tab. It's worth saying this is not the only way of doing this, right? And a question I got, I'm bringing this up because this was something one of the CS members brought up, was I use the sudo apt get install command for getting a package. What this does is this downloads it from a group of recognized packages that already exist in Raspberry Pi. We also have pip. Pip is used with Linux. I think pip3 is used for Python 3 packages. But pip in general downloads uncompiled versions directly from the Python Foundation. So what that means is it may take a little bit longer, and I'm not sure if there's as many packages available. But that's why I'm using sudo apt get install right here. Anyway, let's get into it. So yeah, first, and this gets a little bit nuanced here, is I run this command, which is sudo apt get update. And what this does is I was trying to think of a sort of a metaphor for this week. And I think the best one is like, let's say you're shopping for clothes, but Black Friday is in 2 days and the clothes are regular priced, right? You never quite know that there's a sale going on until you refresh that page, right? So it could even be Friday, and if you have your computer open for 2 days, nothing's on sale because you haven't refreshed to the next version. The same thing's going on with the sudo apt get update. Basically, what you're doing is you're telling the Raspberry Pi, give me a list of all of the most recent software I can receive. And it says, all right, yeah, I'll download that. I'll get a little bit of info about the most recent version of packages that I can give you. This is generally good practice before you're installing anything to use this command. Then what I do is I do sudo apt get install. right, I installed this strangely named package, or I actually installed two packages, believe it or not. So the Python RPI GPIO and Python 3 RPI GPIO. So these are for different versions of Python. In general, Python 3 is the newer version. I haven't done a lot of work with Python 2, but there are slight differences with each version in like regards to what sort of syntax there is. But anyway, Raspberry Pi can do both depending on what you tell it to do. So I try to install this. Okay, we're reading the packages, doing all this stuff. I mean, if anything, the terminal is just a bunch of word vomit that you have to kind of get through from line to line. So there's a lot of information here, but what you see at the bottom is 0 upgraded, 0 newly installed, 0 removed, blah, blah, blah. So what that means is I already have the package. So I'm all set here. And I did it just to demonstrate. But let's go on here. So I'm going to go to the desktop. I think that's a good place to put our Python script. So I decided to move to the desktop here using CD. And then I create the actual Python file itself, which is blink_led.py. Excuse this is an error. So, but what you're going to do is you're going to use something called the nano editor. This is a within terminal editor for the Raspberry Pi itself. And it's kind of cool. You don't have to actually access the desktop itself. You can actually just program live code directly into the Raspberry Pi over your own computer in terminal, which is, I mean, it's kind of interesting. So you run this command here. You're brought to this line. You're brought to this screen, right? And you're allowed to, put your Python code in. This is just some random Python code I found on the internet. And I feel like it would work. I tried to test it. There was some package issue, but that was probably from my Raspberry Pi and not from this. But anyway, this is what I'm doing here is I'm importing the actual package that allows me to work with the GPIO pins. I want the sleep function because I want there to be a break between different blinking sequences. So there's also a lot of just stuff within the actual package itself that you can, set a bunch of specifications about. I'm not super familiar about this, but the point is, you can set it such that, say, pin 8 is an output. So this is the point of a whole GPIO pin, where it can either be an input or an output. And so we're saying pin number 8 is going to be an output, and initially it's going to be low. So there's not going to be any output. And let's say while true, so it's just going to go forever. There's no case that's going to stop this from ever ending. So essentially, when I run this, it's going to flash forever, the LED. So it's going to be on high mode, which means it's going to have high voltage. It's going to be on, essentially. It's going to sleep for a second, and it's going to, so not sleep for a second, it's going to be on for 1 second, and then it's going to be off for 1 second, and then it's going to continue infinitely. So I think what I did here is I hit Control X. For Control Y. There's a lot of different hotkeys that you can use to work with these different text editors, and I think a quick foray into that would be really important. There's a lot of different hotkeys, especially considering that you don't have the convenience of having access to a nice desktop. There's various things you need to do to get these things to work correctly. So yes. Well, all right, we've done this. We ended on this line here, which is nano blink led.py. So we now have a file. We created a file, and now we did editing to it, right? We pasted in that little code that would allow us for LED to actually blink. And now we're going to actually do something a little more important, right? This is what's going to actually allow it to happen in the first place upon boot. So I'm going to do sudo. As you remember, that is sort of like the run as administrator sort of function for Raspberry Pi. And I'm going to go to the cron table. And by executing this command, if you'll notice, the Raspberry Pi realizes, hey, you don't have one of these, right? You've never messed with it before. You've never manipulated this. So I'm just going to give you an empty one and you're going to mess with that. So I do so. And I'm given, this page here. This is actually in the same type of editor earlier that opens, but this is called the cron tab. You make your way down to the bottom. There's more above that I couldn't show, but I'm going to enter a command like this. At reboot, meaning when reboot occurs, I'm going to run in Python this particular script. And I'm going to add an ampersand at the end because that means that it's going to run in the background. So I do so. And in theory, if I save this and I close out of it and I reboot the Raspberry Pi, I should have a nice blinking LED at the end. Right? Okay. So this is our last task. And I mean, our most complex, maybe in terms of software, is a little bit easier than the last one. But someone else asked about this, so I want to cover it. And Rebecca, I know you have a lot more experience in regards to controlling motors than I do. So if you have anything to say, feel free to interject. I think this is a simple example based on what I found online. So we start with our Raspberry Pi. There's like a little block diagram here. There's two things we need to control some motors with the Raspberry Pi, right? We need an external power source because motors tend to drive very large currents. We need the Raspberry Pi itself. These are going to feed into a controller, and then that is going to go towards the motor in regards to actually controlling the motor, making it move in a certain direction at a certain speed. So, and again, if you ever look at the slides later, there's a bunch of links that I put in here that might help you with all this stuff. So the motor controller is for allowing the external power source to power the motor, right? The Raspberry Pi itself, I wouldn't trust it to give an ample power to run a DC motor. And it's also for controlling the direction and speed of the motor. This is achieved primarily through pulse width modulation, which means like what the duty cycle, I believe, of the actual motor is, depending on for what amount of the period of the pulse it's actually powered. And the more often that it's powered in a pulse, the faster it rotates. So this here is an example of something I found online. This is a simple IC. And then we don't get too worried about this pi header here. This is just, I assume, some sort of device which is able to connect to the GPIO pins remotely somehow. But you can just imagine this being the Raspberry Pi itself. And then we have ourselves some nice AAA batteries. These are going to run our DC motor. And if you notice, we have pins 4 and 17 connected to the input of the controller IC, and the outputs are connected to the motor terminals. Right? So let's interpret this here. You can see if we can find 4. 4 is here. 4 goes into the actual IC. And 17 is right here. Right? So these make their way in. I wish I had an actual diagram of the IC, but this is, I don't want everyone to understand this exactly. This is rather just an example more than anything. In general, we just have this external supply that's going to be powering the motor, goes through the IC, and then this also goes into the IC, right? So the important thing is we have pins 4 and 17 that we're going to need to control because that's how they interface with the IC here. So this is just some code for how we'd actually do this, right? We import the GPIO module as just IO. It's a little bit easier to work on. There's some various code that is in regards to how it's actually going to be modulated, actual power of the motor. We just name our different pins here. We set up these as outputs. So 4 and 17 are now outputs. And this is setting properties with regards to some of the pulse width modulation properties. And yeah, so there's just a lot of actually initializing the work with the actual IC. And then we create some functions here for either clockwise or counterclockwise rotation. I think clockwise, oh, there's only clockwise here, right? But I think if you wanted to go the opposite direction, you might just flip these two. But yeah, we have IA outputs. So these mean that, yeah, by making this true, we're going to give output in regards, so by doing this, we're going to be turning one of them on or on high and the other one in such a way that it is sort of the lower ground. And at that point, we're able to kind of control the motors, right? So while true. Direction is F, blah, blah, blah. This is just, the point isn't for you guys to understand this exactly. So I know this may be a lot, and I personally haven't studied it super intensely myself, but the point is, more than anything, is that you can use Python to connect software with hardware, right? You can use these, you can simply, even if you find a script online and you edit it to some degree, you can find something that will allow you to get some software input. You can sort of control which pins give a output that will actually connect to an IC, and then you can do real world things with that, right? So that's a nice advantage. And I mean, that's kind of the point of not only this presentation, but also the entire X1 project, is getting software and making it so we can make things move and do cool things. So with that being said, I actually think it's been 35 minutes. I mean, I think that's it for me, honestly. So does anyone have any questions really quick? Or not really quick. I mean, you can stay as long as you'd like if you have any questions, you think. But yeah.
I'll put in another note, which is these are super great examples. I mean, these are kind of the first things that we involve with robotics wonder about using Raspberry Pi is like, you know, how do you use GPIO pins? How do you control motor? How do you control lights? How do you access different sensors? And the great thing about Raspberry Pi is once you understand these very basics of you set up this weird screenless computer and you connect to it, there's so much documentation online of how to do all kinds of different things with it, all kinds of code that's already written. So don't feel like, you know, because we didn't go over everything it's possible to do today that you won't be able to figure it out, because as soon as you just are a little familiar with it, it's like the whole thing just opens up. Yeah, so that was really, I think, the point of the workshop today is like, if you have a thing, how do you connect to it? How do you get started?
Yeah, for sure. Yeah, it's worth saying that I didn't expect you guys to just study every single line of code that I wrote. I mean, truthfully, most of it is stuff I just found off the internet for the motor controller, for example. But yeah, some of the earliest stuff's pretty important, especially like the first task, moving around, manipulating stuff. But yeah, the important message is, you know, if someone else's code works, why not use it, I guess. You know, and the other thing too is, yeah, it's not just that I think there's a lot of available code. There's an entire online store based on Raspberry Pi compatible products, right? There's like the Adafruit Industries, which is pretty much, they sell anything, literally anything and everything that will work with Raspberry Pi. You can get cameras, you can have different types of microphones, analog digital converters, just a whole bunch of different items that are purpose built to work with the Raspberry Pi. And there's, of course, naturally accompanying that is the fact that there's just a ton of documentation on how to make it work. So yeah.
Yep.
Sorry with my camera, guys. It's the sunset.
Also, if you haven't written in Python before, you know, say that you have taken some CS classes, but you're like, oh no, everything's only written in C++. I'm not gonna have any idea how to write in Python. It's like the same. I mean, you just like the syntax is a tiny bit different. And if you read something and you're like, I wonder what that means, you just Google it. It's amazing how quickly you can get in the habit of writing stuff in Python. Yeah. So I don't think you did go over this. Yeah, Arduino uses a language that is very similar to C++. So it's going to be almost exactly what you see in CS31 and 32. Raspberry Pi, the scripts use Python. That's why Pi is in the name, even though it's spelled differently. I don't know. There was like a tradition of naming computers after fruits. I think even outside of Apple. So that's why they named it that. Yeah, but Python should be used for any of the scripts you're running on it.
Yeah, definitely. There's actually a built-in C++ like environment, but it's really just, I don't know anyone who uses it. But
yeah, I didn't know that.
Yeah, it just comes with it if you just open up the desktop. But yeah, I don't see why you'd want to do that, especially since everything is built around Python with the Raspberry Pi. It seems to be.
Yeah.
So,
Another thing you can do with a Raspberry Pi is you can connect an Arduino to it, which is, it gets very big brain, I know. You can basically the same way that you run an Arduino off your computer, you can run an Arduino off your Raspberry Pi. So then immediately a Raspberry Pi has way more pins, way more processing, like just because it can run things through Arduino. That's the strategy we use for our robots as well.
yeah, I think Broombot's using that, right? So
yeah.
which is awesome.
We got a question. When would you use an Arduino over a Raspberry Pi?
First thing that I would consider saying about this question is just a fact. It's that a Raspberry Pi has around, either, depending on the comparison, about more than 100 or 1,000 times more processing power than an Arduino. And that means that if you have a very complex task that involves a lot of different moving things, I definitely suggest a Raspberry Pi. But if it's something very simple, like an example that I gave was like the hobbyists trying to make sure that their lights turn on at night, right? It's a very simple process of just a for loop, and then just like a sort of a reaction to that information, where like there's a case, and then all of a sudden we turn the lights on. So it's just a really simple sort of thing. I think that sort of in the same vein, you could definitely use an Arduino for, I think we're using it for like controlling motors, right? On Broombot.
Yeah. So on Broombot, I can show the controls diagram if that would help illustrate it a little bit.
Yeah, sure. Do you want to share?
Y'all remember that. Let me give it a second to pull it up. On Broombot, we use Raspberry Pi as the main sort of brains. So there's one Raspberry Pi that's running a lot of scripts that are interfacing between all the different components, which is potentially something that takes more processing power. And then there's another Raspberry Pi that is running the code that generates the touchscreen display. That is something that would be very, very difficult to write in Arduino, if it would even be possible, because Arduino doesn't have as many libraries for making GUIs. I'm sure it has some, like you can use an Arduino to generate like an LED display. But basically they're using Python to make a GUI, and then they have to be running the touchscreen off of that.
Yeah. I think another big point, and you just touched on it, was you cannot like multitask with an Arduino. It simply is too small brain to do that. Like you simply need to commit it to one task, and that means, you know, either having like one, if there's a whole bunch of random stuff you can jam inside a for loop and just make it do. That's not really technically multitasking, but the point is, generally it just works within one loop, and there's no way you can do multiple things at once. So.
Yeah, I think the term for that is single versus multi-threading. I don't know a ton about that, but that is a thing. Here, I can share the diagram.
Yeah, I'm gonna stop sharing. Okay.
Sure. Yeah, so a lot of you guys have seen this before. This is how the controls work on Broombot. So the green boxes are Raspberry Pis and the blue boxes are Arduinos.
So Rebecca, I can't quite see.
You can't see it?
Can anyone else see it? Like I can't see it right now.
Oh no, I can't see it either.
You can't? Okay. You try again? Weird. I don't know.
So do you see like, okay, does it the other thing on my screen?
Huh? Okay. See if I can find it.
I think Rebecca froze.
Oh man. Okay. One down. All right. I'll see if I can find the actual behavioral flowchart here. So this is what she's referring to here. So it's a really nice diagram. Nope, that's not it. Okay, yeah, I'll just share my screen real fast. Erin, can you go check in with Rebecca if you're in the same apartment with her?
Yeah, she's trying to log on again.
Okay, for sure. In the meantime, I have something. Right, I think this was discussed. So you can see we have a lot of the Arduinos working under the Raspberry Pi, right? So we execute a bunch of the sort of important commands that require a little bit of more simpler execution here, sort of things. She could obviously explain far more than I could. But
Matt, that's the wrong diagram.
is it?
Yes,
Okay.
that's the old one.
Is it? How long ago was this? Hold on.
Ages ago, we put this in the designer view as like, this is the old one. Go to the BeagleBone general, should almost definitely be in there.
Oh, really? Okay, it's not here.
Yeah,
Because the new one didn't have a Raspberry Pi connected to a Raspberry Pi, right?
yeah, it does.
Or did it? Oh,
We changed it around a bunch of
Okay,
boxes.
there it
There it is.
very nice.
All right, finally.
So
Yeah, there is one connection between a Raspberry Pi and another Raspberry Pi. Larger Raspberry Pi 3 and then a Raspberry Pi Zero is just a smaller version. So that runs the touchscreen, as I mentioned. The touchscreen, microphone, and speaker are all very interconnected in terms of how they function, because you can either tap something on the touchscreen or speak. So that is like the same type of input. So it makes sense for that to naturally be run by the same script. Yeah, and then the main one, as you can see, is just connected to everything. So it's probably going to be using a lot of processing power just trying to interface with all of that. It's got a camera attached to it, so it has to be sending or receiving video. Yeah, a lot of stuff that really an Arduino couldn't do. The Arduinos are mostly relegated to controlling motors, and an Arduino actually does run the face system. So yeah.
cool. Yeah. All right. So that's all. I'll stop sharing here. So, are there any more questions from anyone? I'm just curious. I'm just in the chat here. Oh, all right. Thanks, Heidi. Cool. All right, I'll give it 10 seconds. If not, I think we'll call the meeting. See any last minute questions? All right, cool. I think I'm going to stop the recording then. Yeah.